Hello students, we have already discussed linear programming problem and how to solve it by graphical method and simplex method. Now there is another concept in linear programming problem is duality. We will discuss duality in this video. The term duality implies two or double. In linear programming, duality means that each linear programming problem can be analyzed in two different ways but have equivalent solutions. Linear programming problem may be either of maximization or minimization. There is not at all any problem. Let us take one example of production, that is, consider the problem of production planning where the production manager attempts to determine quantities for each product to be produced with an objective to optimize the use of resources so that profit is maximum. But then is another problem associated with this, which is a manager may develop a production plan but which optimizes resource utilization so that marginal opportunity cost of each unit of a resource is equal to its marginal return, which is also known as shadow price. In this video, our objective is to formulate primal and dual problem and symmetric form of simplex as well as primal and dual forms, general rules and relation between primal and dual problems. Let us start with symmetrical simplex problem. Symmetrical simplex problem, if objective is maximization, then all the constraints must have less than inequality, and if it is a case of minimization, then all the constraints must have more than equal to sign. Like in these examples, in maximization all the constraints are having less than equal to other than non-negativity constraint, and in minimization problem all the constraints are having greater than equal to sign. Let us understand the concept of primal and dual and how to formulate dual from the primal step by step. First of all, a dual variable is defined corresponds to each constraint in the primal linear programming problem and vice versa. Thus, for a primal linear programming problem with m constraints and n variables, there exists a dual linear programming problem with m variables and n constraints. इसका मीनिंग क्या है? अगर प्राइमल प्रॉब्लम में m कंस्ट्रेंट्स हैं तो वो आपका क्या देंगे? डुअल वेरिएबल्स देंगे, और n वेरिएबल्स हैं तो वो हमें क्या देंगे? डुअल कंस्ट्रेंट्स देंगे. तो हेयर 3 वेरिएबल्स एंड 3 कंस्ट्रेंट्स आर देयर, so therefore dual problem is having 3 variables and 3 constraints. So here next thing is, if the objective function of a primal linear programming problem is maximization, then objective function of dual is minimization. Right hand side values in constraints of primal linear programming problem becomes the coefficients of the dual linear programming problem. The right hand side in constraints of primal problem are 10, 2 and 6. ये कहाँ जाएगा? In the objective function of dual problem. So coefficient of first variable, dual variable is 10, second is 2 and 6. कहाँ से आया ये? From the right hand side of primal problem. Similarly, we can have right hand side of dual from the objective of primal. So coefficients of x variables in objective function are 1, -1 and 3. कहाँ आ जाएंगे ये? On the right hand side of constraints of dual problem. Next is inequality signs get reversed in all constraints except non-negativity constraints. All the constraints are less than equal to, here all the constraints are greater than equal to. Now the coefficient matrix. The matrix of the coefficients of variables in the primal in the constraints of dual is transpose of the matrix of coefficients of variables in primal problem. So here coefficients of in the first row, or you can say x1, x2, x3 are 1, 1, 1. So first row becomes the first column of coefficients in dual problem. In the second, 2 minus 1 becomes the second column of dual problem, 2 minus 2 minus 1, and similarly for the third variable. Now here we are having three variables x1, x2, x3 greater than equal to 0. Here little bit mistake is there. Again we are having three variables, so we have to write y1, y2 and y3 greater than equal to 0. And primal problem should be symmetric, then only we can apply these rules to convert this into dual problem. So let us see some more examples. Now in this problem, the primal problem is not a symmetrical problem. How we can say this? For minimization, all the constraints must have greater than equal to sign, but here first two constraints are okay, but in the third there is the inequality sign less than equal to. We have to convert this into greater than equal to, then only we can convert this problem into dual problem. So let us see how we will do it. Now rest of the problem is same except this constraint. We want to convert this inequality into greater than equal to. So how we can convert the inequality less than into greater than or greater than into less than? By multiplying the constraint with minus 1. So it will become minus x1 minus 2x2 minus 5x3 greater than equal to minus 2. Now this problem is symmetrical primal problem. Now easily we can convert this problem into dual as we discussed in the last example. In the dual problem, right hand side becomes the coefficients of dual variables and objective function becomes help us to formulate this right hand side, that is 3 minus 2 6, 3 minus 2 6, and now we will transpose this matrix. So x1 coefficients of x1 are 1 minus 2 and minus 1. So this will become the first constraint 1 minus 2 and minus 1. Second column 2 4 minus 2 becomes second constraint 2 4 minus 2, and coefficients of x3 gives us third line, that is 5 0 minus 5. y1 is there, y3 is there, second coefficient is 0, so there is no need to write the term having 0 coefficient. So how we convert asymmetric primal problem into symmetrical, and then we convert this into dual. Just keep it in mind, whenever a constraint is not having appropriate sign, we will multiply it with minus 1, and less than equal to converts into greater than equal to, and greater than equal to converts into less than equal to. Now we are considering one more example, exceptional case, where a constraint may have equality sign. Now what to do? If it is less than or greater than, we can convert this in appropriate form by multiplying it by negative sign. But here again we want to convert this into symmetrical form. For this we will use this concept. We know if we say a greater than equal to b and a is less than equal to b, and both are true. When both are true, when a is exactly equal to b, then we can say a less than equal to b and a greater than equal to b. So we will convert equality into two constraints. Equality को किस में convert कर देंगे? Two constraints. कौन से constraints हैं ये regarding equality? Highlighted by the blue box. So rest of the things are same, except the third constraint is also not in the appropriate form. So we convert this into greater than equal to by multiplying it minus 1, and we convert this equality into two inequalities. One constraint is having greater than equal to sign, and another is having less than equal to sign. So we convert equality into two constraints having different signs. One is having greater than equal to, another one is less than equal to. Still this is not in a symmetric form. Why it is so? We have converted this into greater than equal to, we convert this into this, but in this third constraint is not appropriate. We have to convert this constraint also in greater than equal to by multiplying third constraint with minus 1. So we are having now finally symmetrical primal problem. Now we can easily convert this into dual problem. Now how many constraints are there? 4. It means we are having 4 dual variables, y1, y2, y3 and y4. Now again the same concept. Here number of variables are 3. It means number of constraints in the dual are 3. So we have converted this into dual as we discussed in the previous two examples. Now look at this. In all these, y2 and y3 are having same coefficient but with negative signs are different. These y2 coefficients of y2 are all positive and coefficients of y3 are all negative. So this dual problem can be written like this. If we consider y2 minus y3 as a single variable, say y. Now, what is the behavior of y in terms of sign of its value? If y2 is greater than y3, then y is positive, and if y2 is less than y3, then y is negative. So a variable which can take any value 0, positive or negative, such type of variable is known as unrestricted variable. Such type of variable is known as unrestricted variable. So from here I want to tell you one more thing. If your primal problem is having unrestricted variable, we convert this unrestricted variable into uh, difference of two positive variables. Suppose karo we are having x3 is as unrestricted variable, so we convert x3, we assume x3 is equal to suppose x4 minus x5. Next two numbers we use it, and you will replace x3 with x4 minus x5, and then you convert this into dual problem. Now there are some rules. Dual of dual is same as primal problem, and if either primal or dual problem has an unbounded objective function, the other problem has infeasible solution. And if primal or dual is having finite optimum solution, then other is also having optimum solution and the value of z is same. Third one we will discuss with this example. Relation between primal and dual. Now this is our primal problem. We converted this into initial simplex table, and we solved this problem by using the rules. So x2 is incoming variable on the basis of minimum ratio, s1 is leaving variable, and now solve this problem. Last simplex table is this. Now look very carefully. Now the solution of primal problem we achieved as x1 is 3 divided by 16, x2 as 7 by 8, and the value of z is 50 into 7 by 8 and 40. Here this is 40 into 3 by 16 is equal to 205 by 4. Now the solution of dual can be achieved without translating this into dual problem and solving it again. We can have an answer from this matrix also. What we do for this, for second solution, that is dual problem solution, we will consider, suppose we are expressing this in w variable. Now at the end of decision variables, first variable slack or surplus variable gives us the value of first dual variable, and just ignore the sign, if your objective is यहाँ पर जो भी है 15 is w1 and 5 by 4 is w2. This is again by mistake I have written x w2, and when we put these values into z w, so we will get 204, or you can say w1 into 3 plus w2 into 5, in दोनों का addition will give you 204. This is how we can find dual a solution of both by solving only one problem, either it is primal or dual. If we consider this as dual and dual problem, and we want to solve, we will solve this dual problem, and we want to write the answer of primal problem, So again, at the end of decision variables,